And now, please welcome a very unique Srdjan Vranac. Please.
Hey, yeah.
The stage is yours.
Thank you. Are you tracking me or something? All right. Let me see my volume. So this should be good. All right. Hi, welcome to the talk, Help the Hackers Get Your Data. So first things first, who the hell am I? My name is Srdjan Vranac. I'm from Novi Sad. I'm a consultant. Been doing this for some 20 years. At this point, I'm called architecture and software consultant, and I make developers uncomfortable and engineers very happy. And as this is a last talk for the day, we are probably going to speed it up. Right. I'm also father of two beautiful girls. One is 9 and the other is 4 months old. If I'm not working or in front of my computer, I'm with my dog somewhere on the trail, getting lost. All right. So here is the full title of this talk, because some conferences have a limit on the input title. Help the hackers get your data if you want to experience some very, 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 very unpleasant things. And depending on whose data they got, even face jail time, right? Yeah, I'm a cynic. I speak sarcasm as a second language or native language. And I have been doing a lot of rescue projects lately, which definitely does not help the situation, because I have been exposed to some very questionable decisions by developers. So let's manage expectations for start, right? If you're searching for the answer, what is the difference between a junior and a senior developer, this talk is not for you. If you're expecting some kind of hardcore security talk, you'll be disappointed. If you're working in fintech, I don't think there is a part of this talk that you haven't heard on a daily basis, and I hope that you are going to stay awake. For the rest of us, yeah, security is important and secrets management is important, but do we know the fallout of poor practices? And please take note that every time I say you, I mean we, because I'm right there with you, making the same mistakes and trying to be better. So, we deal with too many secrets on our daily basis, in our professional lives. Some of them are less, and some of them are more sensitive, right? We don't think about these things. Basically, we get credentials, we shove them in our configuration files, nobody cares, we move along, right? As far as security goes, your average developer knows about OWASP, XSS, CSRF, and that you should sanitize your input. That's about it. We have conferences talking about code quality, architecture, latest, greatest, and whatever, covariance, contravariance, but people actually speaking about fallout of poor security practices besides you're so screwed, not even once, right? On top of that, when I got this idea and when I started talking to C-suites or VPs of engineering or team leads, they were very happy, like, you should do this, you should talk about this is awesome. On the other hand, when I started talking to developers, I was like, eh. At that point, I knew I was onto something. So, I will be talking about secrets management while trying to look at them from the business point of view, right? This talk is aimed at developers who want to become engineers, which means that you're going to have to talk business. In this industry, this still comes with stigma of unclean, right? Which is a shame, because you can do really a lot of stuff. This whole topic about developers talking business is like a whole new talk that is going to come next season to a conference near you. And hopefully you are going to exit this talk with some advices and actionable things that you can do, how to approach this and different subjects. What I'm saying is that you're going to have to take off your developer's hat and put on your business hat. Because in 2018, something called GDPR came to be, along with HIPAA, certification, PCI compliance. Suddenly, a lot of people were interested what you're storing and how you're storing and how secure it is. And suddenly a realization came that the cost of not handling security is too damn high. Because here's your first takeaway, right? We as developers think and deal with deal with cost the same we do, in the same way we think and deal with security. It is simply an afterthought, and it is not an integral part of our application, right? This happens because of a tunnel vision that is prevalent in this industry, where problems of fallout of this kind are considered to be a business problem that has nothing to do with engineering or development. In turn, this mistake can cost a lot of money, because once, and I'm sure that it will happen, it is just a matter of time, when it hits the fan, you want to be in a position where you just shrug and not go into a full panic mode. Now, when we start thinking about security in terms of cost and expenses, it starts to climb more and more on our priority list, right? And if you know how to explain this to management, you will get their buy-in to deal with it. And later you will get their buy-in to do a lot of different things that you want to do, because now they're going to know that you bring value to the table and you care about the business. Now, as some of you, hopefully a lot of you, know that security is not a simple subject and it can be quite wide. For the purpose of this talk, we're going to focus on one part, which might be the simplest to fix and can be a project, product, or a company killer when mishandled. So, let's start with some data points. A median of 1,793 unique keys are leaked every day on GitHub. And as the man says, please spread the love. Commit to Bitbucket, to GitLab, to every goddamn else, because why put your eggs in one basket, right? Let this sink in. Give it a bit of time, right? This is wrong, right? But, you know, it happens. Mistakes are made and all of that, right? Let's try another data point. In the first 6 months of 2019, 4.1 billion records have been exposed in data breaches, right? Again, give it a bit of time. When you do some math, it turns out that that is 27 million records daily, right? Again, is it really that bad? Why am I so pessimistic? Let me put this in another way. This kind of data terrifies me, right? And it should terrify you as well. The fallout of data breaches is long and strong. These kind of data points are what keeps me awake at night. I don't give a rat's ass about your architecture, about your code quality. I care about how these things are handled. Because these things have an incredible potential damage to your business in costs, both direct and indirect. So, what are the common ways of revealing your secrets, right? Short answer, incompetence, ignorance, and hacking. Long answer, leaving your data store publicly available, whether it is Elasticsearch, S3 bucket, MySQL, Postgre, or Mongo, right? In all these cases, some poor soul got a task to set it up, and they didn't bother to read up on security. In case of Mongo, you know what? You're using Mongo, you don't care about users' data, you deserve everything that happens to you. Let that be a lesson. And of course, we have unauthorized access. Suppose somebody gains an access to your server, and it can be done regardless of your setup, which I hope you have. If you're running Docker or Kubernetes, I'm going to assume that you are not running your container under root, and that you are running the latest version that has the most recent CVEs patched. If you have a dedicated infra or ops team, hopefully they have some kind of monitoring in place. If you don't, I hope this is the least setup that you have. This example is basically a Tripwire that is going to send an email once an SSH connection has been established, right? Which means that the person who is accessing your server, it operates under the assumption that there actually is a Tripwire. And once they log in, the countdown starts. So they have a limited amount of time where they can scoop up as much data as they can and then sift through it later. So if you have this Tripwire setup, you will get a notification. You will check with people who are supposed to have access to the server. If nobody has it, you can take steps like taking server offline and proceed from there, right? In this case, if you put all your secrets and credentials in your config or parameters YAML, you just handed the keys to your kingdom to somebody else because you were nice and hospitable. And you're about to experience a lot of unpleasant things. From incurring a cost for a security incident review by independent consultants, to losing profits due to your application being down, to losing your customer trust, to potential lawsuits. And your bestest code will do nothing to save you from this. On the other hand, your attitude toward cost and secrets management might. Of course, secrets, credentials, config files, whatever, they are quite easy to commit to your repository, and then weird stories might happen. So, I have two of them. Excuse me, I need to take a sip. There was a person a couple of years back. This was long before AWS stepped their game up. And they were creating an application. They wanted to have their bestest code available. So they had an AWS account, and they used an unscoped IAM key, which, in all their wisdom, they just committed to they put into their config file, and then they're committed to repository, right? What could possibly go wrong? They forget about it, a couple of months pass. They, by accident, make the repository public for 15 minutes. During those 15 minutes, somebody scanned the repo, picked up the key, move along. Afterwards, they made the repository not public anymore. But at the end of the month, they got a $15,000 bill, which is a nice chunk of change for 15 minutes. Back then, GitHub did not have any kind of security check for that. But after that, they introduced it. So now when you have a suspicious kind of commit, which contains something that looks like IAM key or your credentials or whatever, that commit is going to be flagged and going to wait for somebody's review. Now, this is a thing that happened to me. Let's talk about the setup. So imagine you have an application that needs to do a lot of crunching, so people who come at their jobs every day at 6 a.m. have the data ready, right? This is something that uses a lot of computing power, so it is running on AWS. We are using Spot instances, we're using EC2 instances. We're doing a lot of crazy things, right? And one fine morning, we get an email from Amazon. They tell us that a key that has been associated with our account has been caught in the wild. We have no idea how that happened. At that point, we go through our logs, we figure out that it was never committed. Whatever happened, happened, because that key has been deprecated 6 months ago. We tell that to Amazon. Amazon says, OK. We say, OK. We move along. Everything is fine. 6 months later, again one fine morning, 6 a.m., I get up, I start my machine, open my nice dashboard, and I see that a lot of systems are not working, that the counters we have are not receiving data, and those that are sending data are way above acceptable thresholds. All right, let's see what's going on. Well, I log into AWS console, and that is when the roller coaster starts. As I said, the application is leveraging Spot instances because they are dirt cheap. They are gone. To make matters even more fun, even the Spot instance requests are gone as well. EC2 instances that are running, they are fine, but I cannot spin up anything new to compensate for the loss of computing power. This is going to be trouble. This is going to be a long, long day. At this point, I'm trying to contact the AWS support. I'm not getting back any response. Time passes. We are 3 hours into the outage. I have some 3 hours more before people start coming in on the morning shift. And I need to have at least some part of processing ready, right? I'm calling the CTO of the company. It is S o'clock in their time zone. They just send me to voicemail multiple times. I have nothing to do, so I try to remodel the application to at least start scrunching. We are now around 6 a.m. Eastern Seaboard time. CTO wakes up, they come online, see the missed calls, voicemails, we start talking again. And now I realize that I just had a masterclass in chaos engineering. The email that was on file for AWS support is not an email he uses often, meaning once, maybe twice a year. It took him about an hour to actually find the password. Once he logged in, he found that Amazon actually tried to contact him, but there was nobody to respond. And so fine, he calls the AWS support, clears it out with them. Another 2 hours pass. We are now in hour 8 of the outage, and information is now coming in about what happened. The key that I mentioned at the beginning of the story that was deprecated, where Amazon said it was OK, for some reason was flagged in back audit. And Amazon decided to protect us by blocking our account, right? And of course, they used the email on file to notify us. Now that everything is cleared, the account will be restored in the next few hours or an hour or so. I ask about the spot instances or whatever else is missing. They say like no luck, they are gone, as it is the policy to shoot first and ask questions later. And this one, so next couple of hours, this one is on me. I spent putting things back together because I didn't have it automated. So 16 hours or so, we are back in business and operational. Can anybody guess what is the damage? Just a ballpark number. All right.
5 figures.
What? 6. For those 16 hours, the damage done in loss of sales is a loss of revenue, is about $1 million US. And some 300 people who were stopped from working, who were prevented from working, are going to get their wages. So it is actually a lot higher, right? But you know, you're more sophisticated than this, and you're more enlightened, so you're in with the hip crowd, right? You're going to use environment variables, and it's awesome, right? I mean, you have your .env file that you cannot commit. So you have a .env file for your local development, you have your .env file for your production. Again, there is some chance of committing, but hopefully you have your ignore file set up. Again, some stupid things can happen in production. I mean, what can possibly go wrong? Right? Do I need to explain this? Good.
Get it off.
Wait, it gets better. Right. Again, if you have your environment variables unindexed, right, and used properly, for a skilled person who has access to your box, it is actually not hard to collect that can actually execute something like this. And again, you're back in a problem situation. But hey, you're using containers. Yay! Good for you, right? So now you're passing environment variables into your container by some way, because why not? Again, somebody can execute a command like this and basically list every variable available to your containers. We are not even going to mention the ever-increasing mess of passing more and more environment variables to containers, for example, via Docker compose file. And as this monster grows, how many hours are going to be wasted by keeping in sync with newly added variables, right? So you add new value to this file, you need to add it to your .env, this file, then you need to pass it to your team. Are we even going to talk about how secure is your way of sharing the credentials? Are you using email or Slack or instant message or whatever, right? Yeah, but you're going to switch to Docker secrets. Sure. Yeah. You're going to tell me that you're going to use a clear text file base located in run secrets and then your environment, then your variable name, right? Please, tell me more about security, please. Even if you squint and pretend real hard that this is not an issue, keep in mind that some of the Docker images you use may contain some kind of vulnerabilities, or they have been hacked. And I'm sure that each and every one of you actually inspects those images before using them instead of trying to play Pokemon because you gotta have them all. So if you're working on a project that has a dedicated infra or ops team, and they let these kind of things happen, please have a talk with them, potentially with, not potentially, basically with business present, explaining why they are ruining things and why they should step their game up because they really need to improve. So, time to look at the consequences of these kind of problems, right? Up to these points, I have been talking about some of those concepts, but they still haven't used their names. So, while you take a sip, here they are. Liability and criminal negligence, right? So here's an experiment. Ask your boss to have a company counsel or lawyer present because you would like to discuss with them what happens in case that when company gets sued after a data breach, right? And you talk to them and they ask you, what do you mean? Well, what happens when we have a data breach? And they go like, how we have that? Somebody gets our data. How did they get our data? Because they got our config files. What do you mean by that? We store our things in clear text. And they go like, what does that mean? And you go, well, whoever gets that file and opens it can read the said data. When you tell that, just sit back, relax, and enjoy the ride. Just see the expression on their faces as that sinks in. You're about to be introduced to a nice term called criminal negligence. But yeah, we have insurance, so we're covered, right? And this is not an issue. Are you sure? Maybe if you have insurance against cyber attack, you might be covered until it is time to actually claim the insurance, and then you have to explain again your reasonable security practices, or when it is time to adjust your premiums, where again you have to explain what you did. I mean, good luck to you. I mean, you got this, you will explain, you will prevail. Sure. No. If you have a good luck to work on a product that has become successful and you're finally starting to get major clients, and one of those major clients tell you, sure, we're going to buy a few $1 million worth of services from you, we just need you to show us ISO 27000 certifications. You're going to find out pretty quickly that certification is a long and expensive project, and that because you didn't care about your security and secrets management and you chased after your best code, you're going to be on a long road, maybe never, and that sale is going to be in question. This is another takeaway. This is why I'm talking about cost and security together, because more often than not, they are the same facet of the business. The cost, damage control, and maximizing profit by not losing sales and decreasing liability potential. So we now know how we ended up in this situation, how it can be improved, right? The solution is kind of simple. Really? All right. Use secrets management applications. So what are they, and what features make a good secret management application? First of all, it is ease of setup and operation. You want to be able to set this up and configure it in a relatively easy way. The configuration should be straightforward as possible and should not be ambiguous. You should also have a clear path to high availability solution or multi-data center solution, whatever it needs. And the way your application interacts with a secrets management application should be as straightforward as possible. It is, of course, also a good idea to have an expiring secret, and that your application should not care about this. All that it knows is that it emits a request and new data comes in. On the other hand, the ease of these changes that your admins or your infra team does is very important, because the simpler they are, the less they're going to cost, and they're going to be more efficient. Now, this is my favorite, dynamic secrets. At first, doesn't mean much, but when you start thinking in terms of business, this suddenly opens up a lot of options, because if you squint real hard, all of your configuration can be treated as secrets, which means they can be shoved into your secrets management application. And then, depending on the token emitted, you get different values back, which means you have one token for production, one token for staging, one token for testing, and then we come to development environment. Suddenly you have a nice reduction of cost and increased security because you're not going to be sharing secrets anymore via whatever, and the downtime that your team or teammates experience by waiting to get the credential goes to zero, which is awesome. Do I need to explain this? Seriously? After GDPR, if I need to tell this to anybody, I mean, you're beyond the redemption. I'm just moving on. Choices of backends. Whether you're going to use local storage or encrypted or RDBMS or AWS or other cloud provider, this greatly increases the value of those security management systems because you can tailor them more to your needs. And let's be honest here, everybody would like the cost to be zero. Of course, that is impossible, but we can do a lot to keep those costs down. By having a straightforward configuration and installation, your team is going to take less billable hours to get these tasks done. By having something like dynamic secrets, as I said, your setup becomes simpler, and you have a much more productive team where downtime due to configuration becomes a thing of the past. Tools out there that do these things, they are out there. There is a lot of them. They are nothing new. This is just a subset. Some of these I found interesting. Some of these, like Ansible Vault, are not really secret management application, but still some people are using them. Some of these are straightforward. Some of these are weird as hell, meaning they require you to recompile the application every time you change your secrets and then deploy them to production, which is like, no. If I have a choice, I like to use software that is backed by a company whenever I can. And of course, we're going to talk about something from AWS because it's ever important and ever present. AWS Secrets Manager, I think this is one of the 2 or maybe 3 similar tools that AWS has. The other one is KMS, and I think there is another one. Yeah, whatever. Ultimately, it all ends up in DynamoDB. Who cares? Yeah, at least it's not Mongo. As I said, AWS ASM is a way of securely storing key value pairs. It has some kind of rotational ability, but outside of RDS, you're basically screwed because you have to write those on your own. And of course, this is single region only. Now, if the region lock is not really a problem, there is a bigger potential issue, and that is the price and the cost, because it can widely differ depending on the usage. So, this is an example from their docs. Example number 1, production scale web application. Nothing special, right? 2 SSH keys, 2 servers, 2 database calls, yada, yada, yada. $6 per month. Not bad, right? We can call it acceptable. Want to try it with microservices? 5 million secrets, each valid for 1 hour, 2 API calls per secret per month. Almost $3,000. That's a hell of a lot of money. You need to really be careful with AWS because more often than not, it is going to bite you in the ass. And again, we're going to talk about another tool, which just skim over it. It's called Hashicorp Vault, which is probably the most commonly heard name when you talk about infrastructure these days. So why it is a good fit? Because it is a small binary to install. The configuration is relatively straightforward. It can use SSL certificates so you can secure your HTTP transport. This can be done by a single developer or a non-dedicated infra person. On top of that, high availability mode is available out of the box, so you can scale it up to console, Zookeeper, whatever, depending on your needs. Of course, the ability to use multiple backends to tailor it better to your needs is present. And then we have some fun things. I apologize in advance. I usually butcher this, so I'm going to try it. Vault, by default, uses a technique called Shamir secret sharing algorithm. Yes. Which has been developed by a scientist called Adi Shamir. It is basically a way to securely distribute a secret by splitting it into multiple pieces. Those pieces are called shares, and these shares are used to reconstruct the original secret. To unlock the secret, you need to define a minimal number of shares that are present, and that share is called a threshold, which means now you have an elegant way to unlock and prime your vault and secrets, even if one of the shareholders is unavailable on top of the mountain, God knows where, outside of cell range. This is another thing that is very important to mention, and that is that Vault operates exclusively in whitelist mode, which means unless you create a rule that allows the access to a certain resource, that access is going to be denied. On the other hand, because you can create multiple rules per user for fine-graining, you need to be really careful, because if you accidentally enable access to a resource, once all those policies are combined, the user is going to have access. So it's kind of a double-edged sword. So everything is awesome, right? Well, not really. There are two issues that come up straight out of the box. One is sealing and unsealing of the vault, because you really need to think about how are you going to manage the encryption shards, who is going to have access to them, how many people need to be present for the vault to be opened, and stuff like that. Still, it's not really a difficult problem, but it is something to think about. The other issue is HTTP calls, because ultimately what Vault does is transport everything via HTTP requests, which means that you need to be very careful about your network infrastructure. Sometimes if your network is overtaxed, you might encounter latency or lag, which you can do something about it. But if you can't do anything about it, you have to suffer with it. On one hand, you have this problem of latency. On the other hand, you have this notion of security and less of a potential for data breach. And for me, it's not a matter of choice. I can live with latency. On the other hand, if you really want to do something about it, you can use HTTP2, because this is a Golang application, so all your overhead goes away. So how does it all fit together, right? Vault token goes into the config file. Yeah, sorry. The token gets sent to the Vault server, and the client token is returned. This is basically like a cookie for your website. Only retrieval of the secrets granted by the ACL is possible. When the lease on the client token expires, the Vault token is used to get a new one. What happens in a case of breach? Your Tripwire system is triggered, your files are downloaded, and possibly your config files as well. You remove the server from public, you rotate the token generated, you rotate all of the configurations and credentials in your Vault. Again, update the config, you make the server publicly available, and you move on from there. And the question that is usually asked is, do I use secret management projects all the time? It really kind of depends. If I'm in a position to make that decision, I have a list like this. So if I'm storing user data, possibly personally in the identifiable information, yeah. Am I storing any kind of secret, sensitive data? Sure. Am I storing any kind of payments on the system? Definitely yes. So I have this list that they go through that gives me a yes or no outcome, basically a cost-benefit analysis. Again, if I'm in a position to make this decision, I will make it. If I don't, I'm going to present it to management. They can say yes, awesome. They can also say no, which is even better, more props to them. I would just like to have it in writing so I can cover my ass when the audit comes. So, final words. Even with these potential drawbacks, using a secrets management application really pays off a lot, because your company or product will be protected from unwanted liabilities, and in case of actual unauthorized server access, your configurations will be stored securely. Because according to the IBM research, a large data breach in which more than 1 million records are lost in 2018 was $3.9 million. This amount includes and takes into account the categories of expenses that arise from the breach: lost business, technical investigations, legal penalties, PR companies, employee time spent on recovery, etc. With this in mind, I believe it is significantly cheaper to invest engineering time to solve this low-hanging fruit than let it run its deadly course. Thank you. Oh, good. Thank you. No questions. Awesome.